Hello and welcome back. So in this tutorial we'll be looking at another question based on conditional trigonometric identities. Here we are given the condition that sum of three angles A, B and C is equal to pi radian, which is pi radian is simply 180 degree. So with the help of this given condition we have to show that our left hand side is equal to the expression on right hand side, which is 2 sine A dot sine B dot sine C. So let's start with our given condition. So here is our given condition. Now I'm going to subtract C on both sides of this equation. So I have A plus B is equal to pi radian minus C. First of all, I'm going to operate this equation by sine on both sides. So I have sine A plus B is equal to sine pi radian minus C, and sine pi radian minus C is simply equal to sine C. Again, I'm going to operate the same equation by cos. So I have cos A plus B is equal to cos pi radian minus C, and cos pi radian minus C is equal to minus of cos C. So we can derive the conclusion that sine A plus B is equal to sine C and cos A plus B is equal to minus cos C from our given condition. Now let me take the left hand side of the equation. Now my first step would be multiply this equation by 2 divided by 2, and we know that this doesn't make any change to our equation. And what I'm going to do is I'm going to distribute this 2, which is our numerator, to all the expression inside the parentheses. So this is what I got on distributing 2 on numerator. Now I'm going to change 2 sine squared A and 2 sine squared B in terms of cos, as we know that cos 2A is equal to 1 minus 2 sine squared A. We can write 2 sine squared A is equal to 1 minus cos 2A from this formula. So I'm going to substitute 1 minus cos 2A in place of 2 sine squared A. So here in place of 2 sine squared A I can write 1 minus cos 2A, and in place of 2 sine squared B I can write 1 minus cos 2B, and for this 2 sine squared C I'm leaving it alone for now. Now let me add 1 and 1 and see what we have. So 1 plus 1 is equal to 2, and let me take minus common from cos 2A and cos 2B, so that I have 2 cos 2A and plus cos 2B for 2 sine squared C. Once again I'm leaving it as it is. Now let me apply the formula for cos C plus cos T, as this expression is in the form cos C plus cos T, and the formula for cos C plus cos T we have here is 2 cos C plus T by 2 dot cos C minus T by 2. So here we have 1 by 2, 2 minus, and then 2 cos C plus T by 2 is simply cos 2A plus cos 2B divided by 2 dot cos C minus T by 2 is 2A minus 2B divided by 2. Finally I have minus 2 sine squared C. Now I can simplify cos 2A plus 2B divided by 2 as cos 2A plus B divided by 2, and simply write cos A plus B instead of cos 2A plus 2B divided by 2. Similarly, for cos 2A minus 2B divided by 2, I can directly write cos A minus B, and that would be my next step. Now for cos A plus B, we can see over here, for cos A plus B, I can write minus cos C. So on doing that, we have 2. This minus changes into plus, as we have changed cos A plus B in terms of cos C, and cos A minus B, and finally 2 sine squared C. Just a minor change over here. Now for this sine squared C, since I have here cos C, I'm changing sine squared C in terms of cos C. We have sine squared C is equal to 1 minus cos squared C, and I'm applying the same formula here. So this 2 I'm writing it as it is, and for this sine squared c I'm writing 1 minus cos squared c, and let me distribute this 2. So let me see what I have after distributing 2. I have here cos c and cos a minus b, and then minus 2 dot 1 is simply minus 2, minus and minus is plus 2 cos squared c. Now we can cancel negative 2 and positive 2, and then we have 1 by 2. Here we have 2 cos c dot cos a minus b, and then here we have plus 2 cos squared c. Now let me take 2 cos c common, and then I have cos a minus b here, and then cos c. Now I can apply the formula for cos c plus cos b once again, and then we know that cos c plus cos d is equal to 2 cos c plus d by 2 dot cos c minus d by 2. So let me apply the same formula here, but first let me cancel this 2, and then I have cos c, and for this what I'm going to do is I have 2 cos c plus d by 2. c is a minus b plus d is simply c dot cos c is a minus b minus, and then I have c over here divided by 2. Once again, let's look for this expression. We have here cos a plus c minus b by 2, just minor rearrangement, and for a plus c, from our given condition, what we know is a plus b plus c is equal to pi radian, and for a plus c I can take b to the other side, and then I have pi radian minus b. So let me substitute pi radian minus b instead of a plus c, and then I have here pi radian minus b. I have another minus b here divided by 2, so this leads to pi radian minus 2b divided by 2. This implies cos pi radian divided by 2 minus 2b divided by 2 is simply b, and cos, here it is in the form cos 90 minus theta, and we know that cos 90 minus theta is equal to sine theta, so here we can write sine b directly. Now let's look for another expression. Here we have cos a, and I'm going to take minus common, and then I have b plus c divided by 2. Now from our given condition, we have a plus b plus c is equal to pi radian, and for b plus c we can directly write pi radian minus a. So let me substitute cos a minus, and then I have pi radian minus a instead of b plus c divided by 2. Cos, let me distribute this negative sign, then I have cos a minus pi radian, and then plus a divided by 2. Let me write it over here. I have cos a plus a is simply 2a, and then I have minus pi radian, and then divided by 2. So I have 2a divided by 2 minus pi radian divided by 2. So this gives cos a minus pi radian divided by 2. Once again, what I'm going to do is I'm going to take minus common, and then I have pi radian by 2 minus a, and we know that cos of minus theta is equal to cos theta, so we can write cos, I can directly, or I can simply neglect minus sign, and finally cos 90 minus a is equal to sine a. So I can write sine a for this expression, and I can write sine b for this expression. So finally what we have, so I can finally write 2 from here, and then for this I can write sine a, I have sine b, and finally here is our cos c, and this is our expression on right hand side of the equation. This is what we have to solve. I hope it is clear to you, and thanks for watching.